and then this guy up here, the antiderivative, and you had all those derivative relationships that you studied. For example, I might say little f is increasing, and that means that you know something about f prime. What do you know, everybody? What do you know? The original function is increasing, so the first derivative is?
Positive.
Positive, good. Little f has a relative maximum. Can you guys draw in the air for me a relative maximum? What does a relative maximum look like? Just about everybody is doing this, and that's true, but there's another way that you can have a relative maximum. You guys are all sort of focusing on the smooth one, but there are those cusp point kinds as well. Say that word with me, cusp point. There you go, cusp point. Both of those are considered maximums because what happens is the function changes from increasing to decreasing, which means something happens with the derivative. What happens with the derivative at a maximum?
It changes.
Changes. What's the change?
From positive.
Function was increasing, then decreasing, so the derivative makes a change from
Positive to negative.
Positive to negative. I know it's a Saturday morning, I know it's been a while since you've done all these things, but I can also tell you that 20% or more of the questions you're going to see on the exam this coming week have to do with those f prime, f double prime relationships. So I'm going to stop talking for the next 5 minutes. It's going to be just a buzz of conversations. Page 1 of your handout summarizes all those f prime, f double prime relationships. And here's how I would encourage you to have the conversation. Find somebody that you're going to sit with, and one of you is dude, one of you is bro. And you can say, dude, what do we know if the original function is concave up? And then you can be like, bro, what I know is that the derivative is, if you look at the concave up column, what do you know about the derivative? Increasing. The derivative is increasing. What else do you know, bro? The second derivative, what do we know about the second derivative?
Positive.
Positive. You've got 5 minutes. Dude and bro have the conversation about all those relationships. They're going to be heavily assessed. 5 minutes, go. Jose, we're filming, right?
Yeah.
I'm looking good? Okay.
Starting a conversation.
It's concave up. If you're showing the bottom part, then the top part is up there. If you're showing the top part, the bottom part is up there. So like it could be like big F, it's close it's increasing.
3 more minutes. Keep talking about all these derivative relationships. Did we go on this thing?
So 0 is concave down, what is f double
Yes. So a cusp point is a type of critical point. A critical point is anywhere where your derivative is equal to 0 or undefined. So at a cusp point, the derivative is undefined. That's why a cusp point is a type of critical point. Or you're learning punch chart. Okay, so wizards know the punch chart. Explorers know the stairs. Yes.
Like this slope.
It worked really closely with my chart and Mrs. Lindsay for a long time.
What do we know? Does F prime exist if there's a
All right, when I say calculus, you say ready? Calculus? Calculus? Okay, well done. Thank you. Voices are off at this point. So here's the plan. I want to look at some multiple choice questions. Kayla, if you could forward up to the next page. We're going to take the next 12 minutes. There are 4 multiple choice questions that I'm going to work through on the board just from start to finish. And as much as I want to call and be like, I want to get some hands on this and be like in total teacher mode, that's not going to work right now with a group this large. So for the next 12 minutes, my goal is to work through and like model the solution for all 4 of these. If I am going too slow for you, keep going, okay? Don't let me slow you down. For some of you, I might go too fast. Just roll with it. It's going to be okay. My goal is to hit that like middle group and go, God bless, and go at a good pace. And you're going to drive the phone here, so just make sure I'm not overspending my time, okay? When that timer goes off, what's going to happen is we're going to switch into practice mode. And so there's a bunch of multiple choice practice questions that you're going to work on in your groups. I'll circulate, float around, make sure everybody is good. I'm going to restart my timer. And then we're going to spend the last 20 minutes looking at a free response question, because it's that free response question especially where you can earn a whole lot of points or lose a whole lot of points because you're not doing things correctly. So 12 minutes, here we go. All right, so question number 1, let f be the function given by f of x equals x cubed minus 6x squared. When will the graph of f be concave up? This is the question, and I would think that this is a pretty standard question that I would expect a lot of you already know what to do and how to approach it. And just quick show of hands, how many of you guys are pretty sure you know what to do? Okay, good. You should just go. So here's what I would think. F is this function, okay. And they want to know when f is concave up. If you need to look at the table, look at the table. If f is concave up, the things that I know f looks like this, and f prime is increasing, and f double prime is positive. Those are all the things that I know right away. I don't have a graph. I don't have access to my calculator. What I know is this. If f is x cubed minus 6x squared, well, I can find the derivative, right? This is power rule stuff. That's not too bad. I would assume everybody knows the derivative. What's that derivative? 3x squared minus 12x. So f prime is increasing. Well, do I know where this graph is increasing? Not really. I don't have the graph in front of me. Let's go one more derivative, f double prime. And I bet everybody knows that derivative. 6x minus 12. F double prime is 6x minus 12. Could I figure out where this is positive? Absolutely. And the way that you do that, it's your number line test. And with the number line test, the way that you're going to do it, you say, let me first set f double prime equal to 0. Let me find the root first. I can solve that pretty quickly. And we're going to get x is equal to 2. At x equals 2, your second derivative is 0, not positive. But what that means is, are there any other places where f double prime is going to have a root? Are there any other places where the second derivative could be equal to 0? No, there's just one, at x equals 2. Everywhere else, all other values, your second derivative is either going to be positive or your second derivative is going to be negative. Because this is a continuous function, once your function becomes positive, if there are no more roots, it has to stay positive. If it's negative and there's no more roots, it has to stay negative. And so what you would normally do with your number line test, you pick a test value, like x equals 1 and x equals 3. You plug them both into your second derivative. At x equals 1, if we plug in 1, what are we going to get here? F double prime of 1 is 6 times 1 minus 12. That is 6 minus 12 negative. The second derivative is negative at 1, and because there are no other roots, it has to be negative the whole time. If I pick another test value like x equals 3, f double prime is 6 times 3 minus 12. 18 minus 12 is 6. Positive. The number line test helps you organize your thoughts and organize your work. It's not that answer. It's not the final answer. The final answer is, where is f double prime positive? Well, that's going to be right over here for all x values greater than 2, and that we would pick A. Are most folks in the room feeling okay with that? Okay, I know it's been a long time since we've looked at f prime, f double prime. It's been a long time since the number line test, but this is the kind of question I would hope is pretty comfortable, really high scoring question for all the friends that are in the room. Okay, Kaylin, if you could scroll up for the second question. Everybody at your group, take a minute, read through this, have a quick strategy conversation. What would you do?
Yeah.
Because it's increasing. All right. So some conversations I heard, we focus in on this adjective twice differentiable. Twice differentiable means that your derivative exists and f double prime exists, meaning that everything is smooth. Your derivatives exist. No jumps, no breaks, no issues. Well, they didn't give me an equation, they gave me a graph. They're asking me to compare the values of f of 1, f prime of 1, and f double prime of 1. Unlike the last problem where there was an equation that we could take derivatives of, there's no equation. All of your answers are going to have to come from the graph. And what's this a graph of?
F of x.
This is the graph of f. And those College Board folks, they're constantly being really tricky with this stuff. They'll say it's the graph of f, it's the graph of f prime, it's f double prime, whatever. Based on the graph, are there any of these values that I know for sure? F of 1 we know for sure has to be equal to 0 because f has a root. Okay? Now what about f prime of 1? Is there anything we know for sure about f prime of 1?
Positive.
It's going to be positive. And the reason it's going to be positive, what's f doing?
Increasing.
F is increasing, so f prime has to be positive. Great, f prime is positive. Now, do we know what positive number? No. It's not about knowing what positive number, but I know that f prime has to be positive because f is increasing. The last piece, f double prime of 1, there's something else that f is doing. At this point, how is it bending? What's the concavity here? F is concave down. And so if f is concave down, you know something about f double prime. F concave down, f double prime has to be negative, so f double prime of 1 must be negative. Negative what? I don't know. We're never going to know the actual value, but I do know f of 1 is 0, f prime of 1 is positive, f double prime of 1 is negative. So what's the answer here?
J.
Has to be J. Because whatever f double prime of 1 is, it's negative, which is smaller than f of 1, which is smaller than f prime of 1. Good. All right, Kaylin, keep going. All right, number 3. This one is calculator active. If you have access to a calculator, feel free to pull it out and use it. You do them all the time. Be careful with your graph. Make sure you know what graph you're looking at. Make sure you've got the right window going on here. And, oh, baby, please make sure you're in the right mode. There is one mode in calculus class, and that is radian mode. Anybody in here in AP Physics? Right, you guys have the challenge of AP Physics, you're in degree mode all the time, AP Calc, you're in radian mode all the time. If you're smart enough to be in both, you're smart enough to keep them both straight. All right, this morning when I graphed f prime, my graph looks like something like that. On the interval 0 to 2 pi. The first derivative of f is given by this. This is f prime. How many points of inflection? Points of inflection, well gosh, I know things about points of inflection. If at a POI, f prime makes a change, that changes from increasing to decreasing, or the change is decreasing to increasing. F double prime makes a change. That changes positive to negative, or we change negative to positive, and these are appropriate abbreviations. You have to keep in mind the graph you're looking at. This is f prime. If this is f prime, can we figure out the number of times f prime changes increasing to decreasing? Okay. Absolutely. So let's count it out. How many do we see here? We've got a change over here from increasing to decreasing. Another one over here, change from decreasing to increasing. Any others? There's one up here from increasing to decreasing, and one down here from decreasing to increasing. So if all goes well, you got 4. And everybody's good? Everybody's good. All right, yeah. One last one from me, and then you guys are going to work with all of these other good-looking folks. Oh, Kaylin, thank you for knowing what I needed. You might also want to shrink it, maybe get down to like 73%.
Exactly.
Okay. Oops. Last one, not a College Board question. This was my question. I wrote it. I love writing your exams and making teenagers cry all the time. Yeah, I know. I know. Evil man. All right, last one. Let f be a function defined on the closed interval -4 less than or equal to x less than or equal to 5. F of -3 is equal to 1. The graph of f prime, the derivative of f is shown above. As soon as I read that, I'm going to take some action. Which graph? F prime. A student needs to approximate the value of f of -2.7. Okay, I need to find f of -2.7 using the tangent line to f at x equals -3. Tangent line at x equals -3. And then determine if the estimate is an overestimate or an underestimate. I need to find the tangent line. Finding an equation of a tangent line is something I would expect we're all really comfortable with, really familiar with. You need 2 things. You need a point, and you need the slope. The point You're going to find f of negative 3. The x value is negative 3. What's the y value here? F of negative 3 is equal to 1. The slope comes from f prime of negative 3. What's f prime of negative 3? Where's that going to come from? You can stop that. We're going to look at the graph. This is the graph of f prime. What's the value of f prime at negative 3?
4.
F prime of negative 3 is 4. 4 is the slope. 4 is the slope. Negative 3 comma 1 is the point. I'm a big fan. I always write like L of x. I take the slope. X minus negative 3 plus 1. Or if you'd like, L of x is equal to 4 times x plus 3 plus 1. That's the equation of the tangent line. The reason that you found the equation of the tangent line is so that you can use your equation to estimate f of negative 2.7. F of negative 2.7 is approximately 4 times negative 2.7 plus 3 plus 1. You just plug it in. Okay. Now, let's not forget, what are we doing? We're supposed to be looking at a student's work. Did they get step 1 right? Their equation of a tangent line seems to match mine. We're good. Is their approximation good? Yeah. Step 3. On the interval from negative 3 to negative 2.7, the graph of f is concave down. Look at the graph of f. Is the graph of f concave down? Don't fall for it. Don't fall for it. What's the trap?
This is f prime.
This is f prime. This graph is concave down, but this is not f. This is f prime. If I look from negative 3 to negative 2.7, somewhere over here, what's f prime doing? F prime is increasing. So what's f doing? Check, fun chart people, use your fun chart. Everybody else go to page 1. F prime is increasing. What's f doing?
Concave up.
F is concave up. They think the graph is concave down because they're looking at the graph, but it's the wrong graph. So step 3 is their error. My last question for you all is this before you guys get some practice time. Now that we know F is concave up, you guys draw concave up for me? F is concave up. What does that look like again? Concave up looks like this, right? What do you know about those tangent lines? Your graph is concave up. Where are all those tangent lines going to be? They're all going to be below the graph. So what kind of an estimate? Has to be an underestimate. All the friends are good? All right, good. You guys are going to have from now until 9:40 to work on the next batch of multiple choice questions. You're not going to finish them all, and that's okay. But it's going to be a buzz of conversation. I'm going to float around, check out the good-looking people, stay away from the uglies. And Kayla, if you could advance to the free response. Jose, we're still filming?
Do you want me to stop?
Nope, no. Okay, for the folks watching this at home, for the next 12 minutes, we're going to be working on multiple choice questions. If you have access to the packet, keep working on those, and I'm going to share the answers when the timer goes off.
goes from negative to positive.
Does anybody else have extra handouts?
It's just like really vulgar.
Extrema will have to change from positive to negative or negative to positive. At this point, it's not changing. Because
Oh, excellent. Thank you. Thanks.
oh, because it's from increasing to decreasing.
Yes.
So you're gonna add something. It should still be from increasing to decreasing because it should still be from positive to negative, negative to positive. Like whenever you have a f that's like that has like an extrema, that means this one is going to be go from increasing to decreasing. Whenever it's a negative prime. It's going from positive to negative on f, but on f prime it's going to be from positive. On f it's going from decreasing to decreasing, and then for f prime it's going to be from positive to negative, or from decreasing to decreasing to negative to positive. So, like that. What chart is this one?
Okay, you and your partner are doing well. If on number 5 you picked B.
What chart doesn't really help you with Mexicans? Other than like knowing the question, that's like no. Oh, what's this?
Okay. 5 more minutes. Use this time wisely. If you need some help, let me know. Get paid a whole lot of money to help teenagers. Really not a lot. Kaylin, you okay back there?
No, because it's
Yeah, this one.
Yes, sir. Smart and good looking, just like me. That wasn't Number 6. Yeah, good choice. Good choice. Yes, sir. Holy. Yes, the data points have to be increasing, so you already threw out these two.
Negative side is the slopes they have to be.
It has to be increased. That's to be concave down and
Yes, ma'am.
the secondary video is negative, then it's concave down.
I think it's pretty straightforward. No, I mean, I would hear about
So, if this is f prime, to get f, you have to find the antiderivative, so you integrate, and this is not a function I would expect you to be able to work on. Hey! Good morning, Andy. Just want to grab sounds good.
So that's like there's two different times.
Alright. Alright, friends, here come the answers. These are going to be answers with no explanations, just answers. Number 5 is B. Number 6 is F. Number 7 is E. Number 8 is G. 9, B. 10H, 11D, 12H, and 13A. Okay, I'm really curious. Now I realize some of you got like 3 or 4 problems done. Some people have like all 9 of them done, and that's fine. Show me on your fingers, please. How many of the ones that you did you get right? Hold them up high so I can see. I'm seeing 3, I'm seeing 3s, I see some 3s. Somebody gave me a finger. I'm going to cut that finger off if it's a mean finger. Some people are using 2 hands. Impressive, impressive, impressive. So here's the thing in the multiple choice. The multiple choice, they're going to show up in so many different kind of ways. I would encourage you beyond this session, if you didn't get a chance to look at all those multiple choice questions, spend some time between now and your common assessment later this week. Make sure that you do look at those. We've got 18 minutes left. I was hoping for a little bit more. We're going to look at free response. And this is going to be a tough free response question. Tough on purpose. And I want to change up my plan. Originally I was going to give you guys a couple minutes to work on this on your own. And we're just going to go whole group through this so we can get as much of this done as we can. Alright, so give it a quick read. Mark this up. Make sure you know what graph you're looking at and that you don't start making silly assumptions. The graph of a differentiable function f is shown above for -3 less than or equal to x less than or equal to 3. The graph of f has horizontal tangent lines at -1, 1, and 2. F is the antiderivative of f. Oh boy. Big F is the antiderivative of little f, which means that big F prime is equal to f. Little f is differentiable. I'm writing these things up here because Kaylin's going to scroll in a little bit and we won't be able to see. Which means that f prime exists. F has horizontal tangent lines, which means that f prime is equal to 0 at -1, 1, and x equals 2. These are, important things. We may or may not need them. Okay, part A asks the question, find all values of x in the open interval -3 to 3. Only give me answers that are between -3 and 3. Don't go outside that, for which the function big F has a relative minimum. Big F has a relative minimum. Think about that for a second. What does that mean? How does that help you? Big F has a relative minimum, but this is the graph of little f. Big F has a relative minimum. What that means is that big F prime, which we know is f, if big F has a relative min, what's happening with big F prime? Big F prime has to make a change from negative to positive. Because big F has a minimum, big F prime, which is equal to f, makes a change from negative to positive. Where do I have a change from negative to positive? At x equals 0. And that's it. That's all they wanted to know. In terms of how we're going to award points, you always have to make sure that you are telling me about the graph that you see. So making this connection right here gets you the first point. Big F has the relative min. Big F prime makes a change from negative to positive. The second point comes in when you say, oh, that means at x equals 0. If you do the first part but not the second, you only get 1 point. If you just list x equals 0 but you don't include your reason, you might actually get no points. Always make sure your justifications go back to this graph. B, on what open intervals contained in -3 to 3 is the graph of big F decreasing Big F is decreasing and concave down. Have a quick conversation with the folks near you. How are you going to figure out where big F is decreasing and concave down? What do you look for here?
Yeah, so that has to be negative and decreasing. That's where it's
Okay, looking pretty good. I saw this on a couple of papers. If big F is decreasing, tell me about that derivative, which is little f. What's little f doing? Little f has to be negative. If big F is decreasing, the derivative is negative. Big F is also concave down, so little f has to be decreasing. You need to look at the graph, and the question you're asking yourself is, where is the graph going to be negative and decreasing at the same time? Kaylin, can you show me the graph again just real quick? Little f has to be negative and decreasing. Kaylin's going to show me the graph. There's the graph. And the only place that happens is here from -2 to -1. Are all the friends are okay? Now be careful with your notation. Where is this happening? We start at -2 and we go till -1. At -2, are you negative and decreasing?
No.
At -2, you're equal to 0. You don't want to include the -2. At -1, is it negative? Is the graph negative?
Yeah.
Is the graph decreasing? Depending on your calculus teacher, here you might have the parentheses or you might have the brackets, depending on what your teacher has taught you. They're both going to be accepted. -2 has to be open parentheses because you're saying that you need to be negative, and at -2 the graph's equal to 0. All the friends are good. All right, let's keep going. All right, part C. Kaylin, can you get, there we go. Part C, assume that f of 1.1 is equal to 2 and that big F of 1.1 is equal to -3. Use the tangent line to f at x equals 1.1, estimate the value of big F of 1.3, determine whether your estimate is an overestimate or an underestimate. I'll give you a minute, see where you can go with this one. This one's worth 3 points. Yeah. So, problem here.
She doesn't even take it.
That means you have to talk to me about each of them. You need to look at this side of the graph, so you have problem. So each Alright, we're going to pull it together in about 30 seconds.
How'd you get it?
Oh, it's going to be positive. So it doesn't matter if it's positive or
Alright. Conversations are done, please. Okay, need the equation of the tangent line at x equals 1.1. So I need a point and I need the slope. And I'm seeing a lot of folks getting confused here because we've got f of 1.1 is equal to 2 and big F of 1.1 is equal to negative 3. One of these is giving you information about the point and the other one is giving you information about the slope. The slope comes from the derivative. Which one's the derivative?
F.
Uh-oh.
Little f.
Little f. Lowercase f. Capital F is the antiderivative. So the point comes from this guy here. The coordinates of the point are 1.1 comma negative 3. The slope at 1.1 is 2. So your equation of a tangent line is going to be 2 times x minus 1.1 minus 3. Saw that in a whole lot of papers. If you get that right, you get the first point. Nice. Now we need to estimate big F of 1.3, which means just plug it in. 2 times 1.3 minus 1.1, the whole thing minus 3. That's great. I hope everyone in the room, regardless of the school that you go to, you know, leave this. Don't do anything with it. Don't simplify. Nobody needs to know what the number is. You're wasting your time. Now the last question, and this would be helpful to have the graph, Kaylin. Is your estimate an overestimate or is it an underestimate? And you got to be really careful here. This is the tricky part that everybody gets wrong, including calculus teachers sometimes. What graph are you looking at?
Little f.
We're looking at
Little f. Little f. Here's x equals 1.1. Here's x equals 1. This is just my estimates, right? For 1.1 less than x less than 1.3. What's little f doing? Little f is decreasing. What does that mean about big F's concavity? Big F is concave down. Think about those estimates. Little f is decreasing. Big F is concave down.
So it's an over.
So those estimates,
Overestimate.
the estimate is an overestimate. Is an overestimate. If for some reason you just had overestimate, you can earn no point for that. If you say little f is decreasing, big F is concave down overestimate, you get no point for that as well. You have to mention the interval. And the interval has to contain your point of tangency, where you build the tangent line, and the point that you're estimating. That's what has to be true. Are friends okay with this? Okay, let's keep going, Caleb. Part D. All right, ooh, that was not what I wanted to take with me. Part D, let h of x, what? Where did h of x just come from? I made it up. Let h of x equal f times or f of? F of. H of x is f of sine of x. Determine if h is increasing or decreasing at x equals 0. To have a conversation about increasing or decreasing, you either have the graph in front of you. We don't have a graph of h. Your other option, talk to me about the derivative. What's the derivative of h doing? We're okay with this thought? You've got h, you have an equation. Go give me the derivative. Oh, so sorry. You okay?
It'll be
You're not going to see me, right? That's not why you're going to put it again. F up. Yep. F up. Keep going. Gonna let you dangle for a little bit, Mr. Harvard. Yes, sir. Okay. Somebody pull it together. All right. We've only got 4 minutes. H prime. At this point, you have it or you don't. Because this is f of sine of x, the derivative is f prime of sine of x times the derivative of the baby. Chain rule. Derivative of sine of x is cosine of x. How many guys honestly had that as your derivative? Nice, you just picked up the first point. Now, why did you find the derivative? Because you need to talk to me about h prime of 0. Well, that's f prime of sine of 0 times cosine of 0. You're going to have to do some work here. Hopefully you know what sine of 0 is. Sine of 0 is 0. Hopefully you know what cosine of 0 is. 1. You guys sound so thrilled about that. So f prime of 0. H prime of 0 is equal to f prime of 0. What I need to know, though, is what is the sign, the SIGN of the derivative? Is that derivative going to be positive or is it going to be negative? Oh. You've got the graph of f. What do we know about f prime at 0? And how do we know that? This is f. What has to be true about the derivative here? What's f doing at 0? F is increasing. If f is increasing, f prime has to be positive. If f prime of 0 is positive, then guess what? H prime of 0 is positive. So what's h doing? H is increasing at x equals 0 because h prime of 0 is positive. In terms of points, you'd probably get the first point for finding the derivative. You'd probably get the second point for getting down to h prime of 0 is equal to f prime of 0. And then I'd say the last point for your conclusion. We've got 2 minutes left, just enough time for one more part. Okay? I never end early. Ever. Just ask my kids, they're always late to their next class. Yeah. Calculus, most important class of the day. Okay, part E. Oh my God. Now we've got G. And it's an integral. What? For what values will G be concave up? We've got the graph of f in front of us. G is the integral of f. But I want to ask where G is concave up. And I know we've only got a minute left. Here's the key. If G is concave up, what's true about G prime? Is increasing. Now you could also say that G double prime is positive, and that's true as well. I don't have a graph of G in front of me, right? So I can't look at the graph. Can I talk about G prime?
Yes.
A couple of people said yes, and to find G prime, you have to take the derivative. You need to take the derivative of this integral of this function, the derivative of the integral of a function from a constant to a variable. There's this theorem.
The fundamental theorem.
It's the second fundamental theorem of calculus, the second FTC. And the second FTC says, when you take the derivative of the integral of a function from a constant to a variable, what happens?
It's just the original function.
It's this guy here evaluated at the new variable. So you're asking me about G prime. What this means is I need to answer the question, where is f of x increasing. Where's F increasing?
1 to 1 and 2 to 3.
F is increasing. Oh, I have that graph in front of me. Where's F increasing? From -1 to 1 and from 2 to 3. And that's that. Okay, that one was a push. I know that one was a push. Thank you all for coming. You are not going home yet. Where do you guys go next? What room?
P122.
P122. You get an amazing person in P122. I think P122 is to the right. No? To the left. Follow and explore.